In problem number 38, we have a fairly complex problem here. We have tables, we have graphs, we have a number of questions, multi-step problem to be solved here. And so it's very important that we develop strategies for how to work through this type of problem. So, how do you see it? The table and the graph show information about students enrolled in Spanish and French classes at a high school. So, in the Spanish classes, there are 355 students enrolled this year. So that's a starting value. And the average rate of change is 9 fewer students each year. So in Spanish, you start with 355 and you're going to be going down 9 fewer, subtracting 9 for every year on average. So making an equation for this, we would get Spanish is equal to, similar to problems that we've done earlier, you have a one-time amount. In this case, it's the starting amount. And then subtracting 9 times the number of years. And that should tell us what the enrollment in Spanish classes is for so many years after the current year, or what the graph says as years from now. The French classes start at 229 students, and they are going up. So plus 12x. They're increasing at an average rate of 12 students per year, or there are 12 more students per year. So what you can see then from the graph is the blue line, which is the Spanish line. Notice where it starts. It starts at around 355, and it is going down each year by 9, whereas the red line, which is the French line, is starting at about 229, and it is going up by 12 each year. So what does the intersection of the two graphs mean? Well, the intersection of the two graphs would tell us the point at which enrollment in the two classes will be the same. The intersection of the two graphs is the number of years from now when enrollment in both classes, I shouldn't say classes, it's really in both subjects, will be the same. The intersection of the two graphs is the number of years from now when enrollment in both subjects will be the same. And this appears to be around 6 years or at 6 years. To be at or around 6 years from now. Okay, so use the graph to determine after how many years there will be equal enrollment in Spanish and French classes. How would we use the graph to determine when that would occur? It's at the intersection point of the two graphs. That's the time in years from now when enrollment in both subjects will be the same, and this appears to be at or around 6 years from now. Now B, how does the equation 355 minus 9x equals 229 plus 12x relate to the graph and the table. So we've already made the equations. And what this equation has done is set those two equations equal to each other. One gives the enrollment in Spanish classes X years from now. The other gives the enrollment in French classes X years from now. We set them equal to each other. We will know when enrollment is the same. Okay, so I've written an explanation there. It says equation F gives the enrollment in Spanish classes. Equation F, and we should add, gives the enrollment in Spanish classes X years from now. The equation F gives the enrollment in French classes X years from now. Setting them equal tells when, in X years, the two enrollments will be the same. And so this is why that equation relates, or this is how that equation relates to the table and to the graph. Now, how can we use this equation to determine whether the answer in part A is reasonable? We would solve that equation for X number of years and we should see that it comes out to equal 6 or very closely equal to 6. So I'm going to scroll up a little bit and we're going to actually solve this equation here. Alright, so we'll do this in purple. We have 355 minus 9x is equal to 229 plus 12x. And I'm going to move that all over just to make sure I have enough room. First thing we want to do is collect our variables on the same side. I can either move them to the left by subtracting 12x, or I can move to the right by adding 9x. In this case, I'll add the 9x. That will help to keep things positive. And I'll have 355 is equal to 229 plus 21x. At this point, I can subtract 229 on both sides. And I get 21x is equal to, and 355 minus 229, if you use your calculator, gives you 126. We divide both sides by 21, and we end up with x is equal to 6. Remember that x is years from now, so that will be in 6 years from now, and that's exactly what we could tell by looking at the graph. And so again, this is a very important type of problem for where we're going with algebra in this year, and that is we'll be given information in tables, we'll have information in graphs, we need to be able to construct equations from either or both of those, and to relate the equations to the graphs, in this case showing the solution to the equation happens to be the intersection point of the two graphs, and what that means is the number of years from now when enrollment in the two subjects will be the same. So we'll stop this video at this point, and please pay attention to this type of problem. It is very, very important.